Hello, can you hear me? Okay, how are you?
Good, good. Much better. How are you?
I am fine. Okay, so now it's start our today's session. So let me share my screen. Can you see my screen? Is it visible?
Yes.
Okay, so let's go. So welcome to monitoring water quality using remote sensing technique in Google Earth Engine. So basically today's session I try to discuss about that how we can easily monitor the chlorophyll, turbidity or total suspended solid. This type of parameter, how we can easily monitor using remote sensing technique in Google Earth Engine. So let's go. I will try to discuss about that first of all theoretical part, then show you that practical part. Then we can easily get the idea how it will work. So first of all, normalized difference turbidity index. So basically, you can see about that. This is the formula about that. So this is the NDTI. It's called the normalized difference turbidity index. So here we can get this type of formula. You can see here we can get the some calibration parameter. So basically AT, then you can see about the BT and C are the calibration parameter, and PW is the red band divided by this is the scale factor about that, and scale factor is set to the 1.0. So basically, this is the formula, and this calibration factor it can be different types of number. Okay, so for the different types of things we have to change it, but it's not fixed. But we have to use the different types of parameter for getting this type of result. For NDTI or other types of parameter, we have to use the different types of parameter. So this is the one kind of formula, NDTI. So here this formula we try to implement in Google Earth Engine, and further we try to calculate NDTI, mainly normalized difference turbidity index. We try to compute, and also you can see this is another thing about the total suspended solid. So basically, this is a formula about the total suspended solid. This formula is that red plus air infrared 1 divided by red, then divided by 2. So this is the formula. Basically, this formula compute the total suspended solid, and here red is the red band, basically before, and we divided this value for rescaling or reproject resample of this pixel value, as well also near infrared 1. So this is the B8 for Sentinel 2 satellite imagery, and divided by this value for resampling this scale factor. Okay, so this is the formula about that. We can easily use this formula, and then further we try to calculate the total suspended solid. And this is a very common formula. We already know about that. So it's called that normalized difference chlorophyll index. So basically, using the Sentinel-2 satellite imagery, we can easily calculate the normalized difference chlorophyll index. So basically, this formula is the red is minus red divided by red is 1 plus red. So when I apply this formula, then we try to discuss about, we can easily estimate the normalized difference chlorophyll index. Okay, so as well as we also try to discuss about the time series chart. Basically, this type of time series chart, how we can easily create it for the turbidity or total suspended solid or chlorophyll. So let's go to the practical session. Just I simply show you that. Okay, so here I already write the code. Look like this code I already created. So basically, this is my study area. So in this study area, I want to calculate this type of parameter. Suppose first of all, here you can see this is the normalized difference turbidity index, mainly NDTI. Then we try to calculate about that total suspended solid, mainly TSS. as well as also chlorophyll.
Okay.
Chlorophyll. And we just implement this type of theoretical part. Suppose for NDTI, we just use this formula. So now I try to explain all of those things one by one in my code, which I try to show you that now. So first of all, here you can see this is the our study area. So basically, this is our shape file, lake shape file. Suppose this is my shape file. This shape file I want to make a boundary shape file of my study area, and then further I try to import this boundary shape file in my Google Earth Engine asset tab. This asset tab, and further from here I just simply import this boundary shape file in my Google Earth Engine. Okay, and I did give the name as the RY. So now further I just simply take a image. So in this time we are just using at the surface reflectance imagery of Sentinel-2, and further we are just simply put this time period. Suppose I want to observe this time period. Okay, so you can easily change it for your own time period for 1 year or any summer season, rainy season, or any specific time. You can simply put in here, then it will work. There is no problem. And filter bounds with my study area. Basically, this ROI is stored in my shape file. So just I simply put at the ROI. And filter metadata. In this time, I choose only for this cloud pixel less than 0.1. Okay, so you try to find choose the less cloud pixel imagery, then we can get that more better result. So after doing, so here you can see we can get that 2nd January, 7th January, 7th January, 12th January, okay, 7th January, okay. So this time we can get the result 5 days interval. Okay, so
Okay.
it's the 5 days. You can see about that. Uh, every 5 days interval we can get the value. Basically, for Sentinel, we find out that 5 days revisit this imagery. So that's how you can get this type of result. 2nd January, then 7th January, 12. Okay. Sometime it also take the same value, but it's why you can get this type of value. Just simply calculate the average. Suppose 8 March, we can get that. Just simply make the average and take the one value. It also okay, no problem. Suppose you can see 23 March, we can get the two value. So simply calculate that average between the two value and take the one day. It also okay. But in the Sentinel-2, we can get the revisit it that 5 days interval. 5 days interval, we can get this type of result
Okay.
for Sentinel. And also for that NDCI, same for the 5 days interval, you can get the result because it will say it also same imagery. And further, for that total suspended solid or TSS, same process I simply call the collection TSS, and then calculate about that average. Okay, and then same process we try to do, and we can just make the time series chart look like that. We can get it this type of time series chart. Okay, so this is the normally we can do, but if you want we can also create this type of web application. Suppose in this time it's not a dynamic, it's just static. Suppose this study area I can easily do it, but if you want to make a web application, then we can easily do this type of analysis for any kind of region. Suppose I will show you one example for my web application which I already developed. So this thing is also added in our online training program. I also show you that for the next class how we can easily do it. So I will show you that. Suppose I simply open this web application. Okay. Suppose here you can see this is that one kind of web application. So using this web application, we can easily monitor for water body. So first of all, we have to create this type of time slider. So from where you can easily put the start date. Suppose I put the time year of 2023 month of January. Suppose 1st January. And second time, suppose year of 2024. Suppose January. Suppose 31. Okay, and draw your study area. Suppose this is my study area. I simply draw it. And which value you want to calculate? Suppose turbidity, chlorophyll, or TSS. Suppose I calculate the turbidity and submit. So now it automatically calculated the turbidity for this water body, as well as also visualize this map. So here you can see it loaded, as well as also show a animation GIF format. Here you can, so we can get this type of legend. So it show about the low, and it show about the high turbidity. Okay, we can find out it's a high turbidity about that, and we also get about that time series chart, when it will be high the turbidity, when it is low about the turbidity. Okay, and further I want to calculate, suppose chlorophyll. Click on the chlorophyll and submit. So now for this time period, what is the condition about that chlorophyll? We can easily get it. So we can get this type of result, this type of map, and this is the legend about that, as well as it also show about that this type of time series chart. Okay, we can get this type of chlorophyll time series chart. And further, suppose I want to calculate the total suspended solid and submit. So here you can see, now it loaded for the total suspended solid. We can get the total suspended solid milligram per liter, and we can easily identify this type of region is the high total suspended solid, this type of region. Okay, red color region, and we can get this type of animation. Here you can see it will show about some changing elevation for different time, as well as it also show about that this type of you can see it show about that high low. We can easily get it for the high low from here. So this is one kind of wave application. In this time, I added only for the 3 parameter. Okay, but I already teach you lot of parameter such as BOD, then COD, or PAs, or LG. So this type of parameter we also added further, added one by one, and I also try to teach you the full wave application, how we can easily create this type of time slider or this type of things, how we can create. I also discuss that, so that I can easily get it, this type of wave application we can easily create, and then you can easily get this type of visualization about that. Okay, so in this time we add only for the 3 parameter, but our main target is that we try to add all of parameter. Suppose which I already teach you using the different function or using the different types of technique, BOD, COD, PAs, or LG bloom. So these type of things we are just combining in one wave application. So anyone or any user, they can easily use this type of software, and they can easily get this type of result. Okay, and easily get. And it is the globally. Suppose I clear this map. Suppose I want to get the result for other study area. So just I simply draw my another study area. Suppose this is my study area. So just I simply put the time period, okay, and then draw the ROI, and simply select this study area. Suppose this is my study area, or river, or lake. So now further I want to click the submit after selecting the TSS. So now it show about that what is the condition about the total suspended solid for this water body. You can see we can easily get it.
When you draw the ROI, like, did you already program it to extract the water body,
Yes,
like in the background?
Yes. For the
Okay.
background, we already select. Suppose when I draw the ROI, it automatically extract the water body. And further, this water body, it calculate about the TSS or chlorophyll or total suspended solid, automatically calculated
Okay.
for any region. Suppose you can see about the other types of area. So I will check for this lake or water body. Or I clear this map, and then further you can simply and draw the ROI. And now I draw it. Okay, and further you can simply choose your, so then you calculate the total suspended solid and submit that. So now it automatically calculate what is the condition about that total suspended solid for this water body. Okay, you can see in this time we can get this type of things. Okay, in this time it show this type of things. It means that for this water body is very cloudy. Okay, suppose I set the in
Okay.
my background code I set for the less than 1%, but for this water body less than 1% image is not available for this type of things. Okay, so that's why this
So
it
the
not
green
show
parts
all
is
of
what's
imagery.
not clouded.
Yeah.
Okay.
So I check it for that. So the
Mhm.
ROI. So you can see it also work, but this part is not show because for this part less than 0.1 or 1% cloud cover is not available. So that's why this part is not loading.
Okay. Bless you. Bless you. Bless you.
So I can see here you can get this type of result, but it not fully fill up because this water body is not available for that 0.1% cloud cover. That which reason is the image is the available, then we can easily get this type of result here again. Okay, so now I can see it fully fill up. We can easily get this type of result
Mhm.
for this lake. As well as the time switch chart, when it will be high low, we can easily get it for this time period. Okay, so you can get this type of result. I also get this type of time switch chart about that. You can see it's so very beautiful for resulting.
Mhm.
Because for this lake is available for that 0.1% image is available, so that's why we can easily get it.
Okay.
Okay? And you can get that when it will be low turbidity, this animation also look more better. Also, this is a legend, as well as you also get about that type of time thing here.
So the 0.1, that was also, you programmed it that way, right?
Yes, yes, yes. Suppose here you can
Okay.
see basically these things in this time, this code I will show you that we have to use the same algorithm behind on this code, okay, for this web application. It's same algorithm or same things in here. Okay, but in this
Okay.
time it's not a dynamic. It's just a static for the specific boundary. We have to draw
Mhm.
our study area or import our shape file. Suppose you can also draw the study area also from here. Okay, just draw your study area and also observe the water body. But for this web application, you can easily draw for this and we can easily get the very dynamic result from that. Okay, so here again we set that 0.1. Okay, but when I increase the value, then this type of place which not show about that water level, then it also show about that. Okay. So
Okay.
okay, so these things I also try to explain. I think I need also more the 2 days. Okay, I need the 2 session for completing also web application. So I also take you more 2 class. Okay, further then I hope you can really get this idea for the web application, because there's a lot of code behind when you create this type of web application. So for that
Uh-huh.
maximum 2 days need for completing the full concept for regarding this thing. But this algorithm is the same. Okay, so I also send you this code. You also try to check all of those things. So in this time it's not a dynamic, it's just a static. So further, you can simply
Uh-huh.
remove your ROI. Suppose I remove the ROI, you draw your ROI. Suppose you can draw your specific boundary shape file or a specific boundary, then you can easily get this result. Suppose I will show you the one example. Suppose I just draw in here. Just click on here and draw the shape of the river. Suppose this is
Mhm.
my study area. Suppose this is my study area. Okay, just I draw from here.
Mhm.
And further I just simply put here ROI. Okay, just I put here the ROI or any reverse shape file or anything. Just simply input and put the variable name is the ROI. Then we can easily get this result for this study area. Basically, 3 map we can get generated from here. One is that NDCI, NDTI, and TSS. So you can say I can get this type of result. Here you can get this type of result for this water body. So it's not a dynamic, it's just static. So you can simply you can simply draw your study area and then you can simply change your time period from here. Also you can simply put here this cloud cover level. Sometimes we can find out that there is no imagery, then you just simply increase this cloud pixel, suppose 1%, 2%, or 3%, then it also work. So in this time we can get this type of result. Here you can see, if you want to simply click on here and then you can simply stressing 98%, and you also get the more better visualization. Suppose now apply.
Mhm.
So now you can see it's very chlorophyll. Okay, we can find out that we're high concentration about that. So NDCI now it's loaded. So you can see. So this is the NDCI, we can get this type of things. And for TSS, just click on here and then custom stressing 98%.
Mhm.
Now further apply. So now you can get that TSS map, meaning total suspended solid map. And further turbidity, just click on here. So basically it's neat for getting the more better visualization for stressing.
Mhm.
Suppose now apply again, just apply. So now we can easily get it loaded. Yeah, so we can get this type of map. So here again, so you can get this type of map look like that. So any water body or any specific river shape file or lake shape file, simply draw your study area, then we can easily get this result. Suppose I will show you for another example. Suppose this is my water body, or this is my water body. So further, what can I do? Just I simply remove the previous ROI, and I simply draw my study area. Suppose I just draw, okay, and further I put it. It's a ROI, and I put here that ROI. Click the run. So now here you can see you can get this type of result.
Mm-hmm.
But it's not fully filled up. And it's more better. Suppose you without take the rectangle, you try to add the suppose this type of polygon drawing. Simply study your river shape file or lake shape file. Then we also get that more better result. Otherwise, sometimes water pixel is also mixing with other object or other feature. Then it also not get the more better result. Suppose in this time I simply draw this R study area of water body. Just
Mm-hmm.
make a polygon, okay, and it's my study area. So now I on the code. So now we can get this result only for this study area, but for this study area there is no image which is the less than 2%. So just I increase the value, suppose 5, and check it again. Suppose I put at the 10. So now we can call the imagery. We can get that imagery. Okay, but we can get the imagery only for this part, but other parts it's missing. I think it's
Okay.
very cloudy place. So that's why I simply put at suppose 50. Work. Okay, so now I can see it's fully fill up my study area inside row. Okay, inside row. And further you can simply check the visualization for the different types of features. Try to add the visualization. You can see this is that NDCI, it's a TSS, or it's a NDTI. We can easily get this result from here. And further click on here and set the more better visualization from here.
Mm-hmm.
So now we can get this type of things here. Okay. So basically this is the process about that. So I will send you this link. You try to explore more and try to study more about this code. Further, if you have any
Mm-hmm.
question, then we try to discuss about the next session. And from the next session, we try to discuss about that web application, how we can easily create this type of web application and observe the water body. Okay, from this dynamic, we can create this type of things. Okay. So in the
Okay.
meantime, I will send you this practice code about that. You also try to check all of details. Okay, and
Uh-huh.
also try to revise our previous algorithm, which I already teach you for BOD, COD, or PS or salinity. Because further class, we also try to add this type of parameter in our web application. Okay, or I will
Okay.
show you for only for the 3 parameter how we can add. Further, you also try to add the more other parameter Then from this variable equation, we can easily calculate all of parameter from our map. Okay. Okay, so I'll send
Okay.
you that. You
You
also try.
said
Yeah,
you said 2 more classes, right?
yeah.
To
2 more class
finish
we
the
take for
web.
the web application.
Okay.
Okay, no problem.
Mm-hmm.
Okay, okay.
Yeah,
Thank you.
sounds good.
Okay, have a good time.
Thank you. You too. Bye bye.